This video is a continuation on my video of multiplying and dividing rational expressions. I'm just including more examples here just to make sure that we have a good understanding of what to do with these problems. So you may want to, after I write the problem, pause it and try it on your own, and then check your answer, check your solution. So let's take a look at this example here. So if I said to multiply, now remember, it could say perform the indicated operation. I'll give you the directions multiply in this case. But if I said to multiply x plus 3, the quantity squared, over 8x squared times 2x over x squared minus 9. So first off, we're multiplying rational expressions. You see that they're fractions, right? That's what makes them rational expressions. And when you multiply rational expressions, even if I said perform the indicated operation, this, time symbol here tells you that the operation is multiplication. So when you multiply, the first thing you want to do is factor everything completely. Now, this x plus 3 quantity squared, don't distribute this through. Don't FOIL this, right? Don't do x plus 3 times x plus 3, because then you would FOIL it, but then you'd have to factor it immediately afterwards. This is already the factored form, right? X plus 3, the quantity squared, just means x plus 3 times x plus 3. 8x squared here, that doesn't factor at all. It's a single term, so we don't have to worry about that. 2x won't factor. X squared minus 9, does that factor? Now remember, we should be looking for, is there a greatest common factor? In this case, no. All right, and then, how many terms? We see 2 terms. You see 2 terms, you're checking for the difference of perfect squares or the sum or difference of perfect cubes. In this case, the difference, are x squared and 9 perfect squared? Well, yes. So that factors. So we're going to factor that out. So we can rewrite this with just x plus 3, the quantity squared stays. We have 8x squared times 2x over x squared minus 9. How does that factor? Well, it's the difference of perfect squares. So x squared gives us x times x. We know one has to be positive, one has to be negative. To multiply to 9, what number times itself is 3 times 3. Now that we factor completely, now we'll go through and cancel any factors that are common between the numerators and denominators. It doesn't matter which fraction it's in, but it only can cancel if they're on different levels. So I have x plus 3 quantity squared, and I have 1x plus 3 down here. So this 1x plus 3 will cancel with one of these. So this just becomes the first power. Because of the same factor, right? This, if I was writing out x plus 3 times x plus 3, I'd be able to cancel one of them with this one, but I can't cancel them both. Here I see I have 2x, and here I got 8x squared. 2 and 8 share a common factor of 2, so 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. We have x and x squared. One of these x's, right, this x here will cancel with one of the x's in here, so x squared just becomes x. Right, you're dividing out an x from each of them. And then you should check see if there's anything else that cancels. The 4x won't cancel any for the x minus 3. So I'm left with this. I have x plus 3, which since I'm multiplying this just times 1, I'll just leave it as x plus 3 without the parentheses, over 4x times x minus 3. And when you look at this, make sure you don't try to cancel the plus 3 and the minus 3. Remember, these aren't the exact same factors, so you can't cancel them. You don't need the 1 times this in parentheses, because 1 times anything is just itself in the numerator, so just x plus 3 over 4x times x minus 3. You can't cancel anything here. And I would leave it like that as a product in the denominator. If you distribute the 4x through, that's okay. Just make sure you do it correctly, otherwise you would lose points. I would leave it in this form though. Let's take a look at another one. If I was to say, let's multiply these two. So again, I'm writing multiply here in the directions, but you could have used perform the indicated operation as a direction, so make sure you know what the operation is. We have 5x cubed plus 20x squared over 30x squared plus 15x times, here I've got 10x squared plus 11x plus 3, and then this is over x squared plus 7x plus 12. So you might want to pause this and try it on your own. Make sure you do copy it down properly. If you miss a sign or don't copy it properly, it won't work out properly. So So try it on your own and then come back and watch the solution. So the first thing here I would mention is that, it's multiplication because of that time symbol, right? If it said perform an indicated operation, you know it's multiplication because of that time symbol there. And then you want to factor each of the numerator and denominators completely. So factoring the 5x cubed plus 20x squared, remember when you're factoring, the first thing you're looking for is always the greatest common factor, a GCF. If you don't look for that first, you might make some errors in here. So 5x cubed plus 20x squared, I first can factor out 5 as a common factor between 5 and 20. X cubed and x squared, the GCF is x squared. And then times, what's left over when you factor it out? Well, I've got 5x cubed, factoring out the 5x squared. It's like dividing it out, remember, so it just gives me x plus 20x squared, factoring out the 5x squared just gives me plus 4. This will be over. In the denominator, same thing, looking for a GCF, 30x squared plus 15x. Well, 30 and 15, the greatest common factor, make sure you get the largest one, is 15. Sometimes people miss that because, 15 and 30 have other common factors like 5 and 3, but the largest one is 15. You want the greatest. X squared and x have a GCF of x. Remember, you want the lowest power you see because the highest one common to both terms. So you factor out 15x, and then what's left over inside the parentheses, 30x squared, factoring out the 15x leaves me with 2x, just like dividing it out. 15x, factoring out the 15x. Make sure you put something here, right? So it's plus. When you factor out the entire term, there's still a plus 1 there. It doesn't just cancel away to 0. You need to put plus 1 there. Really, it's 15x divided by 15x is the way to think of it, as a positive 1. You need it in there. Times the 10x squared plus 11x plus 3. We want to factor that. Now, is there a GCF here? Well, in this case, there's no greatest common factor other than 1. Do you see a value in front of your x squared? Because you have 3 terms, so that's what you're looking for. When I have 3 terms, I look in front of x squared. I do see a value other than 1. That tells me that to factor this, I either have to use, a reverse FOIL trial and error or an AC method. Maybe on this one I'll do an AC method just to refresh your memory on it. AC method, remember this is A, B, and C. It refers to the coefficients. The AC method takes things that multiply to A times C. So it's 10 times 3. So AC is 30. And they have to add, remember, to B, the middle term, which is 11. The middle coefficient, I should say, is 11. So then what numbers do that? Well, the numbers that do this, multiply to 30 and also add to 11, are positive 5 and positive 6. You can try those out just to make sure, right? But it's 5 times 6. 5 times 6 does give you 30. 5 plus 6 does give you 11. And remember what you do with the AC method, right? So when you do AC method, what you're really doing is a rewrite method of the middle term of the 11x. So the 10x squared stays 10x squared, plus the 11x gets rewritten with the 5 and the 6 you just found. Make sure you put x after each of them, so it'll be plus 5x plus 6x. And it doesn't matter which order you put those in. And then plus 3. Now if you put these in a different order, your middle steps will look different, but the factoring part will be the same. Now you have 4 terms. When you have 4 terms, you factor by grouping. To group these, the first group has a GCF of 10x squared plus 5x, has a GCF of 5, x squared and x is 5x. And then parentheses here, when you factor out the 5x, you're left with 2x and then plus 1. The second group here, it's 6x and 3. It's positive, so we know it's going to be a positive here. 6x and 3 have a GCF of 3, so plus 3. It's a plus sign there. So plus 3 times, factoring it out, 6x, factoring out the 3. Remember, just dividing it out gives us 2x. 3, dividing out 3 gives me plus 1 here. So then, now once you have that, you're hoping that these parts and parentheses are a common factor to both terms, which in this case they are. So you factor out 2x plus 1 times, then 5x plus 3 is what's left over from the front of each when you factor that out. So 10x squared plus 11x plus 3 factors a 2x plus 1 times 5x plus 3. Again, if you change the order of these middle pieces, this part would look different, but at the end you should get the same 2 factors, maybe in the opposite order. If you did it by trial and error, reverse foiling this, you should still get the same factors. So we have 2x plus 1 times 5x plus 3. And then factoring the denominator, x squared plus 7x plus 12. I don't see a greatest common factor here other than 1. I have 3 terms, so I look in front. I don't see a value in front of x squared, meaning the leading coefficient is 1. So for those ones, right away, make 2 sets of parentheses because x squared is x times x. You don't want to do an AC method on this. And then you want numbers that multiply to the last term, multiply to 12, and add to the middle coefficient 7. So what numbers multiply to 12 and add to 7? Well, it's a positive 3 times a positive 4, right? 3 times 4 gives you 12. 3 plus 4 does give you 7. So now that we've factored each of these completely, and you know, if these factored further inside of here, you'd have to factor those further. Now we're allowed to cancel. Remember, when you cancel, you're canceling on different levels. So let's take a look. We got 5x squared and 15x. Those will cancel with each other. 5 and 15 share a common factor of 5, so divide by 5 is 1. Divide by 5 here is 3. X squared and x, you know, canceling out one of these x's with one of them up here gives me a 1x up top. The whole thing for that x down in the denominator cancels because you use the whole factor and divide it out. Other common factors, remember, different levels. X plus 4, does that have a common factor in the denominator? It does, so those cancel. 2x plus 1, does that cancel with any of the denominator? Yes, the 2x plus 1 cancels with this one. 5x plus 3, does that cancel with any of the denominator? Be careful here. The answer is no. This is x plus 3. It has to be exactly 5x plus 3 to cancel, so these don't cancel with each other. You can't cancel this 3 at all with any of that. So I'm left with, now remember how you multiply. Straight across the numerators, straight across the denominators. So I'm left with x times 5x plus 3 in the numerator, over in the denominator 3 times x plus 3. And then that's it. You can't cancel any of this. If you wanted to distribute these coefficients through, you could. I'd rather leave it in factored form. Shows me clearly that you knew what you had. Additionally, you know, you could make an error distributing that through. Let's take a look at just a couple more. So for this first example on this page, let's say I said to divide. Remember, the directions could say perform the indicated operation. If I said to divide and I said I had x squared minus 16 over x plus 2, and we want to divide this by x plus 4 over x plus 2. Now remember, the operation's division here because it says divide in the center. So if you didn't see this, it just said perform the indicated operation. The division symbol is telling you what the operation is. So taking a look at this, you know, you might want to pause it and try it on your own. Right? But going through it, when you do division of fractions, right? You're dividing a fraction by a fraction. You know, we multiply by the reciprocal of the second fraction. In other words, we use what we called keep, change, and flip. That's a shorthand way of saying multiply by the reciprocal. So we keep the first one the same. So we keep this as x squared minus 16 over x plus 2. Division will become multiplication, and then we take the reciprocal, which means flip this second fraction, which makes this x plus 2 over x plus 4. Now once we're here, we have a multiplication problem, and now we're allowed to think about, you know, factoring things out and canceling. You can't cancel when you have a division problem. You can only cancel when you have a multiplication problem. So it's very important that you change the division to multiplication first by multiplying by the reciprocal. Now once we're here, we'll factor each of the numerators and denominators completely. The x squared minus 16, remember you're looking for a GCF. In this case, there is no greatest common factor. How many terms do you see? Well, I see 2 terms. If you see 2 terms, it's either a difference of perfect squares or the sum or difference of perfect cubes. In this case, you know, we have the difference, so it's subtraction. Are these perfect squares? Yes, so this factors the difference of perfect squares. X squared is x times x. One of these should be plus, the other should be minus to multiply to a negative. And then 16 is what number times itself? It's 4 times 4. Remember, you have to use the exact same factor as 16 times itself for using difference of perfect squares. You couldn't use, for instance, 8 and 2, because then it wouldn't be what multiplies for the perfect square. X plus 2 doesn't factor any further. No GCF other than 1, so the denominator stays the same. This times x plus 2. That also stays the same. X plus 4, that also stays the same. So not a lot of factoring to do in this problem. Once you have this, now we're allowed to do some canceling. Remember, you can cancel anything on different levels. So I can cancel x plus 4 here in the numerator with x plus 4 here in the denominator. X minus 4 doesn't cancel at all. X plus 2, that factor will cancel with this x plus 2. Now, notice we canceled the whole thing out here. So if I cancel this whole x plus 2, there's really a 1 there. If If I cancel this whole x plus 4, remember there's really a 1 down here. If I cancel this whole x plus 2, remember there's really a 1 down here. So when you multiply this, what are you left with? Well, you have x minus 4 times 1, which will just be x minus 4. Over here, 1 times 1 in the denominator is just 1. And now it'll be simplified completely. If you're dividing by 1, right, any number divided by 1 is just itself. So x minus 4 divided by 1 is still just x minus 4. So the answer here is x minus 4. Alright, make sure you don't keep that over 1 in there. You wouldn't have simplified completely if you do. And I'll take off points if you leave it. You need to show that when you divide by 1, you know, you are simplifying it down to just the numerator. Let's take a look at one more. Similar, but it is different. If I said to divide this here, if I had x minus 4 over 2x squared minus x minus 15 divided by x squared minus 16 over x squared plus x minus 12. Watch the signs on this. So once you have this, you might want to pause it, try it out on your own, and then, you know, check your answer. So first thing to notice, we have division here, right? That's the operation, even if I didn't say divide here. If I said perform the indicated operation, the operation is division of fractions. When dividing fractions, remember the first thing you do is multiply by the reciprocal of the second fraction. So I keep the first, so I keep that as x minus 4 over 2x squared minus x minus 15. We change division to multiplication. Make sure you make that change in the problem. And then we flip or take the reciprocal of the second one, so it's x squared plus x minus 12 over x squared minus 16. The order matters. You always have to do the reciprocal of the second one. You can't use the reciprocal of the first. Once we're here, now we'll talk about, you want to factor, remember, the entire numerator and denominator, because they're multiplication problems. So you want to factor all numerators and denominators and then simplify. So x minus 4 doesn't have a GCF other than 1. Can't factor it any further because it's a linear term, meaning the highest power is 1, so you just have x minus 4. 2x squared minus x minus 15. Is there a GCF here? The answer is no. Don't try to factor that 2 out. It doesn't have anything in common with everything else. You can't take the 2 out. So you don't have a GCF here. And then looking at it, you have 3 terms. You see a value in front of your x squared. Here that tells you either using AC method or a reverse FOIL trial and error. It's up to you which method you prefer. I did AC method earlier. Maybe I'll do a trial and error here just to show you both. You've seen these before. 2x squared means that you have 2x times x in the front of these. Now be careful. This isn't like when you just have x squared where you put x's here, because then you can say multiplies to the end and adds to the middle coefficient. Because this is 2x and x, you can't just say multiplies this and adds to this. You actually have to figure out what the factors of 15 are, or negative 15 are, and then try them out to make sure they work when you go through and FOIL. So some factors of 15 are either 1 and 15 or 3 and 5. You know, one of them has to be positive, one has to be negative to get to a negative. When you do the outer and the inner of FOIL, they should add to a negative 1. So, you know, 15 is a very large number in terms of trying to get to a 1. If you put the 15 here, you get 2 times 15 would be 30. If you put the 15 here, you get 15 times 1. You're not going to get to add to a negative 1 in the middle. So we know 15 and 1 are probably out. So maybe we should try 3 and 5. 3 and 5, you know, if I put the 5 here and the 3 here, I'd get 2 times 3 would give me 6. And here, 5 times x would give me 5. From a 6 and a 5, can I get to a 1? Yeah, if you're taking the difference. We need a negative 1, so the 6 should be higher. So it should be a negative 3, because 2 times negative 3 will give you a negative 6. And then here we'll put a plus 5. 5 times x will be positive 5x. So checking this real quick, 2x times negative 3 will give you negative 6x, plus 5 times 1 will give you positive 5x. Negative 6x plus 5x does give you a negative 1x in the middle. So it factors of 2x plus 5 times x minus 3. If you did an AC method on this, you know, you'd have to go through the steps of doing it. I'd probably do it on the side, and then you'd still get the same factors. Times, here, factoring x squared plus x minus 12. Here, there is no GCF other than 1. I have 3 terms. I checked the leading coefficient. I don't see a value in front of x squared, so there's nothing there other than 1. So that tells you right away you should make 2 sets of parentheses with x times x, because that's how you get x squared. This is where you can say multiplies to a negative 12 and adds to a positive 1, and just use those numbers right away. So multiplies to a negative 12. and then adds to a positive 1, there'll be a positive 4 and a negative 3. 4 times negative 3 is negative 12. 4 minus 3 does give you 1. And then x squared minus 16, we actually saw this in our last example. It's a difference of perfect squares. There's no GCF. So we have two sets of parentheses, x in the front, x plus 4, x minus 4. Because we have to, have a negative, so positive and a negative there. Difference of perfect squares. So once we've done this, now we're ready to cancel any common factors to both the numerator and denominator. And really just do is looking at it. X minus 4, is there a factor of x minus 4 in the denominator at all? Well, there is right here, so the x minus 4 will cancel. Since I canceled the whole numerator there, so just a 1 left, make sure you know that. X plus 4, does that cancel? Well, yes, it cancels with the x plus 4 down here. So this whole denominator got canceled, so there's really a 1 here. Here I have x minus 3, does that cancel with anything? Yeah, I canceled with the x minus 3 down here, so I canceled this whole numerator, so there's really a 1 there. And then the 2x plus 5, well, it doesn't cancel with anything else. So you've canceled everything as much as you can. Now, remember how you multiply fractions. Straight across the top, straight across the bottom. So straight through the numerators, 1 times 1 gives you 1. 2x plus 5 times 1 gives me 2x plus 5. And then 1 divided by 2x plus 5, you have to keep that as the fraction. If 1's in the numerator, you keep that. If 1's in the denominator, like the previous example, that's where you divide by 1 and you still have itself, right? It's the difference between saying a fraction is the same as, if I had 1/2, I have to keep it as 1 over 2. I can't just write it as 2. But if the fraction was 2 over 1, I could say 2 divided by 1 gives me 2. And that's the difference between these. 1 in the denominator, you divide by the 1, you just keep it as whatever the numerator was. 1 in the numerator has to stay there because that gives you the fraction 1 over the 2x plus 5. So hopefully these extra examples helped.